Welcome back to class. Today we are going to be beginning Unit 3, which is rational numbers. On the page you can see that the first slide in our notes today is just telling you what you are going to be expecting to be able to show that you know at the end of this unit. So in this unit you will be extending what you know about adding, subtracting, multiplying, and dividing positive fractions and decimals to negative fractions and negative decimals. More specifically, you will identify positive and negative decimals and fractions as rational numbers, compare and order rational numbers, add, subtract, multiply, and divide rational numbers, solve problems that involve rational numbers, and extend your knowledge of the order of operations to include negative fractions and decimals. So, why is this important, and when will you be using this? If you're ever doing any type of job that has to do with finances, even your own finances at home, keep track of your income, your money, where things are going, it's very important that you have a clear understanding of numbers. When working with temperature, any type of graphing, so that lends itself to science very well. Building contractors to measure and estimate costs. Chefs measuring ingredients, planning menus, estimate costs, ordering supplies, and anything with investment professionals to show changes in stock prices. Okay, so it is going to be something that you are going to see in your lives. It may be in different capacities and to different degrees. However, it is very important that you have a base understanding of numbers. So there are some things that you need to remember from previous years in order to find some success in this section. The first one that we're going to go over is equivalent fractions. An equivalent fraction has the same value, so it'd be like showing on the same distance on a number line. So it's different numbers but the same value. So 1/2, 1 out of 2, is the same as 2 out of 4, 3 out of 6, 4 out of 8. 5 out of 10, 6 out of 12, 7 out of 14. In order to find an equivalent fraction, you have to multiply or divide the numerator and the denominator by the same number. So 1/2 to 2/4, I said 1 times 2 is 2, and 2 times 2 is 4. I could equally have said 1 times 3 is 3, and 2 times 3 is 6. So when I multiply or divide the numerator and the denominator by the same number, I have found an equivalent fraction. So this slide has a kind of a chart which could help you guys. You could use it as a reference point as you guys are working that shows which numbers are equivalent on a number line. At the bottom here, I do have an example. Okay, so to find an equivalent fraction, you are multiplying or dividing both the numerator and the denominator by the same number. So 1/2 times 3 on the top and times 3 on the bottom gives you 3 out of 6. For 8, if I divide the numerator and the denominator by 2, gives me 2 out of 4. Some of you guys remember numerator, the top number in a fraction, denominator, the number at the bottom. So here's a page to do some practice. So as you're watching this video, if you want to pause me and give something a try, you're welcome to do so. Just kind of want to follow along as I'm doing it. You can also do that. When it comes to equivalent fractions, there could be hundreds that are the correct value that give you the same answer. You don't necessarily write them all. So easiest to do is you're normally probably going to multiply or divide by small numbers. The larger the fraction, the more work it's going to be for you in the future. So equivalent to 7 out of 10. If I just multiply both of them by 2, I could say that is 14 out of 20, which is an equivalent fraction. I could multiply them both by 3, which would give me 21 out of 30. And if I repeat the same step, so I'm going to times it by 2, which is 24 out of 30. And if I times it by 3, it will be 36 out of 45. And the last one on this first line for C, if I multiply them both by 2, 6 out of 16, and times 3, I would say 9 out of 24. Question 2 here, write an equivalent fraction with a given denominator. So sometimes you're going to see questions where they're giving you what they want the other fraction, or at least part of what they want the other fraction to be. So if you are doing that kind of question, you need to ask yourself, how many times did it go into the new number you're trying to get? So if I'm going from 5 to 20, how many times did I count by 5 to get 20? So 5, 10, 15, 20. I multiplied it by 4. And what I do to the denominator, I have to do to the numerator. So 3 times 4 is 12. Okay? This B is the same question, but it's going the opposite way. So how many times is 3 going to go into 15? 3, 6, 9, 12, 15. It's going in 5 times. I multiply it by 5. What I do to the bottom, I have to do to the top. My missing number is 10. And same thing for the last question. How many times is 6 going to go into 24? 6, 12, 18, 24. So I'm multiplying by 4. I do the same to the numerator, and that gives me 20. Okay, so I'm hoping this kind of makes sense. What we're going to do this year is we are now going to add in an integer. So we're going to add in our positive and our negative numbers to the work that we are doing. So there's different ways that you can do this. You can still multiply the top number and the bottom number by the same thing. So you can still say something like times 2 times 2, which is going to give me, if it was negative 3 times 2, it's negative 6. 4 times 2 is 8. So you just have to remember that you're keeping your negative there. It was only there once, it should only be there again. Now, other people kind of do like the cheap, easy way to do an equivalent fraction. If the negative is there once, it only has to stay there once. So if I were to just erase this and go back, I could say that 3 over negative 4 is also an equivalent fraction. Okay? I move the negative, it's no longer at the numerator, it's now at the denominator, but it still has the same value. The negative is only there once. If I divided it with my calculator, negative 3 divided by 4 is going to give me negative 0.75, and 3 divided by negative 4 is also negative 0.75. You can also, instead of putting the negative symbol in the numerator or the denominator, you can just put it in the front of the entire fraction and say that it is negative the fraction 3 over 4. And it is still an equivalent fraction. So when it comes to integers, sometimes it's a little bit easier to find equivalent fractions because you don't have to multiply or divide. You can, or you can simply move the negatives around. So I can say that this negative 5 out of 15, I just traded the negative spot, or negative 5 to 15. If I want to switch it up, instead of doing that, I could say times 2, and it's negative 10 on 12 by times 2, or I can make the negative at the top, or I can put the negative at the bottom, and they would still also be equivalent. So I multiply the top and bottom by the same number still, and the negative is still only there one time. Okay, the most important part to remember there, the amount of negatives does not change. The next thing that you need to remember from previous years is how to convert between fractions and decimals. So if you have a fraction, to turn a fraction into a decimal, you are simply using division. So numerator divided by denominator, so 1 divided by 6 gives us 0.166666. It's going to keep going in your calculator. We use the repeating sign on top of the 6 because that's the number that is repeating, and we call it a repeating decimal. If I did 7 divided by 8, that is going to give me 0.875. Okay? This is called a terminating decimal. The opposite, the one that takes a little bit more work, is converting decimals to fractions. In order to convert decimals to fractions, we need to look at place values. So 0.7 is actually 7/10. So the number right after the decimal is called a tenth, which means to make it a fraction, we put it out of 10. So 0.7 becomes 7 out of 10. If I look at 0.23, I know that 2 is a tenth, and the 3 is in the hundredth spot, which means I'm going to put it out of 100, and it is going to become 23. Okay, so we look at place values to create fractions from decimals. Sorry, I'm just going to change my background because it is pretty dark. Alright, practice. Write each fraction as a decimal, which are repeating, which is terminating. So again, if you would like to pause me and do some questions on your own, feel free to do so. If you would like to do them along with me, that works as well. So, as a decimal, 3 divided by 4 is going to give me 0.75. That would be a terminating decimal. 2 divided by 3 is 0.666666. So that is a repeating decimal. 5 divided by 8 is 0.625. That is also a terminating decimal. Okay? Write each decimal as a fraction. The 3 is in the tenth place, so it becomes 3 out of 10. The 7, so the last number in my decimal is in the hundredth place, so it becomes 87 out of 100.